All right, welcome back from the break, everybody. I hope you've had some time to reflect on the talks you've listened to until now. And the next one is going to be about Pons, an async client for Ethereum. And it will be presented to you by Bogdan. So yeah, Bogdan, take it away.
Hey, thank you. My name is Bogdan. I work in Entropy Cryptography, although this project is not directly related to what we do because we mostly code in Rust. And this is more of my personal thing. All right, let's start. So why do we need another client when there's also already a web3.py? When I started this project earlier this year, first what I needed was trio support, and web3.py didn't have that. And also, like, the whole async support was kind of shaky and not very completed. And I just decided that it would be easier to try to write something myself and see if I can possibly improve on the API that that web3.py provides for normal RPC operations and for contracts and for all sorts of other things. So I wanted it to be, of course, strongly typed and easy to mock in the application I was going to use it in. All right, so how does it look like? That's just a quick example of connecting to the provider, checking the balance, and transferring funds. So you see it's fully async. It doesn't have any sync interface, just to make things simpler. All the code should be like pretty much self-explanatory. You call the RPC endpoints, you can transfer, and when you do something that requires your identity, your private key, you need to pass an explicit signer to the method. That's kind of unlike what web3.py does, but I think the explicit version is better. So, so one thing I wanted to improve on is typing. In web3.py, the types are usually new types, which is an alias for an existing Python type like integer, for example, or string for the address. And they are not very restrictive. Like, you can, if you add two amounts, which is alias for integers, you get an integer as a result when you check with MyPy. And I didn't want that because it is better to have, like, when you work with money, it is better to be sure that you're working with correct types. And Pons uses actual types, strong types for addresses and amounts that also host the conversion methods. And if you have multiple networks and multiple currencies, as I did in my application, because I had Polygon and Ethereum, and in the Ethereum I had two different currencies I had to work with. You can derive classes from the base amount to work with different currencies, and you wouldn't be able to use the variables of both of these types in the same expression, so that you're protected from mixing up your currencies or mixing up your addresses from different networks, for example. I had some bugs related to that before, and I decided to just make it impossible to do that. And of course, it is all checked with MyPy when you do type checking, so you don't even need to run tests to notice it. And for example, the conversion to the specific amounts or to the specific addresses happens in the layer where you connect to the contracts. So you see, like in the second method, you call some whatever token contract, and you get the balance, and you convert it, the amount you receive, which is just an integer, the output of the contract, into the typed amount. Then the next thing I mentioned is the explicit signer. I find that it's very important to know which methods require your identity and which don't. So the signer passing is always explicit, and also in many cases you want the signer to do some additional things. For example, the signer may connect to the hardware wallet. For example, you want it perhaps to show a notification that something is being signed, or to ask for your permission interactively, and you can just overload the base class for the signer and do whatever you want in the signed transaction, which will be called somewhere, whenever you do something that needs to be signed in Pons, this method will be called, and you can do whatever you want in it. Right. So I guess the core of the talk is how Pons handles contracts, and that's what I wanted to improve the most, I think. And in Web3.py, you usually have the JSON API that is an output of a Solidity compiler, and it's sort of processed dynamically, and you call the contract methods based on it. So in Pons, there is an alternative. You can declare the contract API purely in Python, like this, which is not even. This is not completely ideal. I would want to use the Python's annotations to do that, but that's like a plan for the future. But for now, even that is a great help because you can declare the part of the contract that you use in your application. Like you don't need to keep up with all the methods. You just, you declare what you want, and you can check that, like you can print this API and see that it actually corresponds to whatever you want in Solidity. And I will explain later also how all the conversions and everything happens between the parameters and stuff. So, but let's start with deploying a contract. You get the bytecode from the compiler, for example, from PySolveCX, and you call the deploy method, which is pretty logical. You pass, of course, the signer because you need your identity, and you call the constructor of the contract that you get, and the constructor can be declared here in this slide, for example. So you know all the inputs that it takes, and this call creates a sort of a bound call object with all the parameters already encoded for the transmission, and then you can pass it to the actual provider to execute. And as a result, you get a deployed contract, which contains inside the ABI and the address of the new contract. Or if the contract is already deployed, you can just pass the address instead, and you will get the same object. And then you can use that contract object to create calls and to execute them, either by ETH call for the read methods or transact for the write methods. Now, what about the arguments? So when you call a method of the contract, you get so that when you create the call, Pons checks all the arguments that they can be encoded into the ABI, and that all the names are correct, and the binding is the same as you would have in a Python method. So it's all being checked. Of course, there's no static type check because I don't know how to transfer this information to my Py, but if I use annotations later, maybe it will be possible. Yeah, of course, like even complicated arguments, complicated types like nested structures, it is all being processed and packed into proper encoded format and unpacked back into the structures. So you see, like I have like two-level nested structure here, and declare a read method that takes and returns it, and it's all being processed correctly. And if you have, for example, a wrong field name, it will be noticed when you create the call and not when you try to execute it. And of course, when a contract raises an error, and the error is declared in the ABI, you will get an actual, it will be recognized and raised as your actual contract error. So you don't have like some weird dictionary that you don't know what it is. You get the actual error type, and the same goes with for the panics. So if you try to transact something that raises a panic or reverts, you will get an error. There's also a high-level system for filtering events. So you can declare an event in the API, and then you can iterate over the events in a sort of this high-level method, which is also asynchronous, obviously. And you get the already passed and unpacked events with all the relevant information. Right. So what about testing? I mentioned testing a lot, and there are sort of several things that you can mock. For example, what if you have an application that uses someone else's contracts and you don't really want to test the contract, someone else will test them. So you mock this level, you mock the Pons level, and you mock sort of the behavior of the contracts for tests. You can create a mock client, which mimics Pons client, and you sort of create this base class for the mock contract that unpacks the encoded data, passes it to your mock contract, and packs back the result. And here is how mock contract may look like. So it initializes some state that it needs. Excuse me. And you mimic this method and do whatever you want with the state in there. And it mimics this kind of Solidity contract. Now, for example, in Pons itself, I want to use actual contracts. So I have to mock the provider layer. Yeah, and sorry. So in the Pons, I have this kind of setup where I have my test provider, which is sort of built on the Ethereum tester, PyVM, and PySolCX. Of course, I could use Ape or Brownie, but they're like too huge. They have a lot of internal state. They have to manage their frameworks and not libraries, so they're just too complicated. So this is much simpler. Yeah, and when I have when I need to test like a contract that I have, I need to test like how that I can call it, that I can catch the errors from it. I can just call this Ethereum tester, which contains a PyVM inside it, and just use it. So it all works. So you don't need any complicated frameworks. It's like a small piece of code that does what it wants, what it needs to. I would like to expose it later for other users, because it may be useful like for other applications to test contracts. But for now, it is internal. And the most complicated part here, as I mentioned here, is to actually translate everything that ETH tester, like the errors that it raises, into the actual RPC errors that you would get from a remote provider, because there's a big difference, and there are some other compatibility things that needs to be done. Right, and yeah, the last thing I want to mention is the API discoverability. Like the type annotations are important. And I just realized that myself, and maybe some people are not realizing it yet, but just give it another thought, because that's something that people writing in strongly typed languages already know, that types are also documentation. For example, what if we want to deploy a contract? What do? We see this deploy method. So how do we use it? We need this thing, bound constructor call. So we'll look for it in the documentation. Where is it? Yeah, we see it, but we cannot create it. So we look for a method that returns it. Or we see with this bound constructor returns it. So how do we get the bound constructor? We get it here from the compiled contract. And how do we get the compiled contract? You see, we can get it from here, from compiler output, or we can create the ABI manually, perhaps. So this creates sort of a direct and explicit pathway. If you use the method, you know where to get the arguments, if you have the types available for you. So that's pretty important for a new user. And that's what I was trying to do with the interface. And I don't want to point figures, but many packages are like in this, and sometimes it's hard to discover, how to do things with them. Okay, yeah, of course, there's a lot of things to be done. I made this library for myself, so it contains what I needed to. But if other people use it, maybe they need something else. So feel free to come to the repo and file an issue. If you need something. And there is a lot of stuff that I plan to do, maybe sometime later. But anyway, see for yourself. Thank you for your attention, and now we have time for questions.
Yeah, thank you so much. And if anybody has questions, please put them in the Discord channel and we will read them out because, yeah, that is the easiest way. And I think one question was already in there. It's about ABI in Pons. Can it still take a JSON string when obtaining it externally from Etherscan API, for example?
Yes. You can create it from JSON also. There are two ways to create it. So JSON is also available. And the same, you can create all the like subclasses, like the methods or the errors also from JSON if you want to.
Okay. Well, so far there are no other questions, but yeah, anybody knows your chance because I think Bogdan said he has to drop off because he has other things scheduled as well. So
yeah,
ask
but
now.
I will be on Discord. If you want to ask me something, please do.
Yeah, just contact him on Discord. Yeah. Yeah, I think it seems there's no other questions, so I think we can wrap it up here. But yeah, thank you so much for joining. And yeah, if you can share the links you have on this slide, for example, in the Discord, that'd be great. So then people can directly go there and check it out themselves. Okay, cool. Yeah, thank you. All right, thank you so much for being part of this and sharing your insights. And yeah. Thank you. Bye. Bye, everyone. Bye.